I am Anil Kumar. Welcome to my series on vectors. We'll discuss 10 multiple choice questions based on equivalent forces. First, let's look into these questions and then one by one, I'll provide you with solutions and the strategies to solve them. Question number 1. Two forces act on an object. The forces have magnitude of 3 newtons and 4 newtons and act at an angle of 35 degrees to each other. What is the angle that the resultant makes with the 3 Newton force? Question number 2 is, a 20 Newton force acts on an object. The horizontal component of this force has a magnitude of 12 newtons. What is the angle the force makes with the horizontal? Question number 3. Which of the following system of forces cannot be in a state of equilibrium? Question number 4. A 20 kg block lies on a smooth ramp that is inclined at 35 degrees. What is the force parallel to the ramp would prevent the block from moving? So it should be what force parallel to the ramp would prevent the block from moving. Question 5. 10-meter long rope is attached to the sledge. Anil pulls sledge holding the rope at an angle of 25 degrees with a force of 300 newtons. Find the force that pulls the sledge forward. Question number 6. Two forces of 40 newtons and 20 newtons act at an angle of 30 degrees to each other. The magnitude of the resultant is what? And in addition to this, you can always find the angle of the resultant, which it makes with 40 Newton force. Question number 7. A weight of 196 Newton is suspended from a ceiling by two ropes that make angles of 45 degrees and 60 degrees with the ceiling. Determine the tension in the shorter string. Question number 8. An object with the weight of 60 Newton is suspended by two lengths of rope from a ceiling. The angle that both length makes with the ceiling are the same. The tension in each length is 40 newtons. Determine the angle that the lengths of the rope make with the ceiling. Question number 9. A 30 kg mobile is suspended from a ceiling by two hooks 50 cm apart. The mobile is attached to the hooks by two pieces of strings on 40 cm and other, there should be one 40 cm and the other 30 cm in length. Find the tension in the 40 cm string. The last question here is, the resultant of two forces A and B is 8 newtons acting due north. A has a magnitude of 5 newtons acting due northeast. Determine the magnitude and direction of B. So I hope you find these questions interesting and useful. You can actually solve them first and then look into my solutions. We'll begin with the solution of the very first question now. Two forces act on an object. The forces have magnitude of 3 newtons and 4 newtons and act at an angle of 35 degrees to each other. What is the angle that the resultant makes with the 3 Newton force? So when you make your diagram, you will place 3 newtons like this horizontally, that is better, and 4 newtons will draw on the other side. Resultant we need to figure out, which will be from the head. We'll place this tail and then sketch 4 newtons, right? So that becomes the parallelogram we're looking for, and the resultant will be from the tail to the head. Correct? We are given that this angle here is 35 degrees. This is 3 newtons. That is 4 newtons. So the angle which we see outside is 35 degrees. Angle between these two, when placed tail on the head of the first one, is how much? So this angle here, let's call this as theta. So angle theta is equal to 180 degrees minus 35 degrees, or 145 degrees, correct? Now we know two sides. We need to find the resultant R. The third side, we know the angle in between. So the situation is SAS. We can apply the cosine law. So we can write R is basically equal to square root of sum of these two squares. This is 4 newtons, right? 3 square plus 4 square minus 2 times 3 times 4 times cos of angle in between them, which is 145 degrees. Clear? So let's calculate this answer. So we have square root, and within square root we have 3 square plus 4 square minus 2 times 3 times 4 times cos of 145 degrees. And that is, there's an error here. Let's go back. I have to close two brackets, right? So two brackets. Now let's calculate. So we get 6.68 to 7, let's say 8, right? So that is what we get. Now we know the resultant magnitude, right? That is the magnitude of the resultant vector, you can say. We need to find the angle which the resultant makes with 3 newtons. So we need to find this angle, alpha. So now we can apply the sine law, right? So we can say sine of alpha over the side known to us, opposite side 4, equals to sine of the angle, which is 145 degrees, over resultant R, which is 6.6828, right? So from here, sine alpha is equals to 4 over 6.6828 times sine of 145 degrees. So let's find this out. So we have 4 times sine 145 divided by 6.6828. That is equal to 0.3433. To find alpha, we'll say sine inverse of 0.3433. So that is shift sine inverse of our answer, which is equal to 20.07. So 20.078, which actually rounds to 20.08. So option A is the right option. Perfect. So to show the calculations, I took so long, but when we have a multiple choice question like this, you could do most of these calculations in one shot, right? Now let's look into question number 2. A 20 Newton force acts on an object. The horizontal component of this force has a magnitude of 12 newtons. What is the angle the force makes with the horizontal, right? So the horizontal component is given to us as 12 newtons. We are given a force here which is 20 newtons, right? So some force which is 20 newtons. This angle is what we need to find. So we know the horizontal component 12 should be equal to cosine of theta, right? So it is 20 times cos theta. So from here we can find cos theta equals to 12 over 20, or we know theta is equals to cos inverse of 12 over 20, right? So let's find this. So we have cos inverse of 12 divided by 20, and that is 53.1. So 53.13 is the right answer. Correct? Question 3. Which of the following system of forces cannot be in a state of equilibrium? So what is the idea here? How do we figure out? So basically, we need to form a triangle, right? Important thing is sum of two sides should be greater than the third. It could be equal or greater than. Is that okay? The third. So if you see this, if I add 12 and 10, we get 22, which is greater than 6. If I add 10 and 6, then also it is greater than 12. So this is okay. 1 plus 2 is 3. It's equal. It works. Now if I look into this, 13 plus 15 is 28. Now 28 is less than 29, so this will not work. You get an idea, right? So sum of these two sides is less than the other one, and therefore it will not form a system which will be at equilibrium. So there will be something, residual resistance, so it will move on. Question number 4. A 20 kg block lies on a smooth ramp that is inclined at an angle of 35 degrees. What force parallel to the ramp would prevent the block from moving? So we have a ramp here. We have taken an angle of 35 degrees. So if there is a block, it is going to be sliding downwards. Now when we say that we have to keep it stationary, not moving, then we have to apply a force which is same as the force because of the block, right? So this force, downward force, is what? It is mg sine theta, correct? So we are given the mass of 20 kg, right? So that force is 20, gravity is 9.8, and then we have sine of the angle, which is 35 degrees. So that should be your answer, right? So 20 times 9.8 times sine of 35 degrees is 112.42. So which is D. So that is the answer for the given question. Clear? Question 5. A 10-meter long rope is attached to a sledge. Anil pulls sledge holding the rope at an angle of 25 degrees with a force of 300 newtons, right? So let's say this is the sledge, right? So it's being pulled at an angle of 25 degrees. The force with which it is being pulled is 300 newtons. Find the force that pulls the sledge forward. So when I say forward, it is again the horizontal component. Now here the 10-meter long rope doesn't have any significance, right? Doesn't matter. So the net force, which is horizontal force, is what? Same as question 4's, fourth. So in this case, horizontal force will be the cosine component of 300 newtons, right? So it will be 300 cos of 25 degrees, which will be the horizontal component, right? We are assuming no friction here. So 300 times cos of 25 degrees, which is 271.89, same as 272. Is that clear to you, right? So that is how we could find the solution. Now here is question number 6. I'd like you to pause the video, answer this question, and then look into my suggestions. Question number 6 is, two forces, 40 Newton and 20 Newton, act at an angle of 30 degrees to each other. the magnitude of the resultant is what? So we are only interested in finding the magnitude this time. So let us say one of the forces is 40 Newton, the other one is 20 Newton, right? So again, we'll complete our parallelogram. So it's similar to the first question, but this time we need to find the magnitude only, right? So let us say this is 40 newtons, this is 20 newtons, these two are same forces. The angle between them is given to us as 30 degrees, so this angle will be 150 degrees, right? Now resultant R we can find using cosine theta. So theta first we found 180 degrees minus the angle of 30 degrees, that gave us 150 degrees. Resultant R is equal to square root of these two squares, 40 square plus 20 square minus 2 times 40 times 20 times cos of the angle 150 degrees square root. Perfect. So we get square root, and then we'll put 40 square plus 20 square minus 2 times 40 times 20 times cos of 150 degrees equals to 58.18. So the first answer A is the correct option. Now here you have to find angle alpha. So this is basically a practice question for you based on what we did so far. Question number 7. A weight of 196 Newton is suspended from a ceiling by 2 ropes that makes an angle of 45 degrees and 60 degrees with the ceiling. Determine the tension in the shorter string. Okay, so let's try to make the diagram. Now for these questions, diagrams are a must. So we have two angles, 45 degrees and 60 degrees, right? So let's say this is 45 degrees. Okay, and from here we have so let me make it longer, right? So and then we'll have a shorter length, 60 degrees. So if the angle is 60 degrees, this is longer, right? 45 degrees shorter. Determine the tension in the shorter string. So this tension T1 we need to figure out, right? So okay, is that clear to you? So the side which is opposite to smaller angle will be shorter. Now here we are given that 196 newtons, right? So it is not weight or mass, it is a force of 196 newton, right, which is suspended. We need to find T1. Okay, so let's make the diagram, the vector diagram now. So 196, we have equilibrate force. So opposite to this will be the force which keeps it in a place, right? Now here we will draw T2 parallel to this. So let me just sketch it like this. Okay. Now before that, let's also find the angle which these two will make. So this angle will be 180 degrees minus 45 degrees minus 60 degrees, right? So the angle here is 180 minus 45 minus 60. 75 degrees. Okay, so let us see how to make our diagram. So T1 is this parallel thing, right? So we'll draw a point here parallel to this, that is T1 for us, correct? T2, so we'll have T2 which is parallel to this. Okay, T2. Now the angles. Now, so when I draw a horizontal here, think like this. This is my horizontal, that's the force. So this is 60, that will also be 60 degrees, right? So these two angles are equal. So what we get here is 60 degrees. Is that clear? Similarly, this one is 45. So with the horizontal, this one here will be 45 degrees. Perfect. We know this side 196, 90 degrees. Two angles. So this angle here will be 45 degrees and here we have 30 degrees, correct? Anyway, we need to find T1. So we can now apply sine law. So sine law will be T1 over sine of 45 degrees is equal to 196 over sine of sum of these two, right? 60 plus 45 degrees. Correct? So if we get T1 as equal to 196 times sine of 45 degrees over sine of 105 degrees. Correct? So let's figure it out. So we have 196 times sine 45 divided by sine 105. 143.48. So the closest here is 143 newtons. A is the correct option. Perfect. So that is how you're going to do it. Now we have similar questions here with some variations. Question number 8. An object with weight of 60 newton is suspended by two lengths of ropes from a ceiling. The angles that both lengths make with the ceiling are same. The tension in each length is 40, right? So in this case, let's again make a similar diagram. So we have two lengths which are same, so it's like same angle, correct? So let's say if this is theta, the other one is also theta. And here we have a weight of 60 newtons. The angle that both makes over the ceiling are same. The tension in each string is 40 newtons. So this is 40 newtons. The other one is also 40 newtons. Determine the angle that the lengths of the rope make over the ceiling. So we need to find the angle theta. So that is the question, correct? Okay. So again, let's make our diagram. So we have a resultant here of 60. Right, so these two tensions, 45 and 45. So this angle theta, the other angle theta, so these are the two angles, correct? And we know these two tensions are 40, 40, and that is 60, correct? That is the diagram. So we can find what 2 theta is. And then the job is done, right? So from here, you can see that the 60 square, which is the resultant, is equal to 40 square plus 40 square minus 2 times 40 times 40 times cosine of 2 theta, right? Now directly also you could write the cos theta formula, but we'll rearrange. So we have cos 2 theta equals to 40 square plus 40 square minus 60 square divided by 2 times 40 times 40. So let's calculate the value. We have 40 square plus 40 square minus 60 square. We need to divide this by 2 times 40 times 40. We get minus 1 over 8. Okay, so the angle is more than 90 degrees. So 2 theta is basically equal to cos inverse of minus 1 over 8. So we'll do shift cos inverse of our answer, and we get this as 97.18. So theta is half of this, right? So half of 97.18 degrees. So divide by 2 is the answer, 48.6. Okay. So 48.6 is close to 49 degrees. So that will be our solution, right? So I hope it is absolutely clear. Now these are very important questions always seen in test papers. A 30 kg mobile is suspended from a ceiling by two hooks 50 centimeter apart. The mobile is attached to the hooks by two pieces of string, one 40 centimeter and the other 30 centimeter in length. Find the tension in the 40 centimeter string. So let's first make the position diagram. So we'll make it here. So these are the two hooks which are 50 centimeters apart. We have two strings 40 and 30 centimeters. So okay, so one of them is longer than the other. So let's say this is 30, the other one is 40. And a mobile is suspended, which is 30 kg. So when we are given mass, we have to multiply that by 9.8, right? So this one is 30 times 9.8 newtons. Clear? Now, in this example, we are given the three sides, so we have to find all the angles first. And we need to find tension in this string. So the tension T1, let's call this as T2. We need to find what T1 is. Okay. So first let's figure out the angles. Let's call these angles as alpha and beta. Okay. So to find alpha, we can say cos of alpha is equal to these two sides, which is 30 square plus 50 square minus 40 square divided by 2 times 30 times 50, right? Okay. So we have 30 square plus 50 square minus 40 square. We'll divide this by, within brackets, 2 times 30 times 50. So we get 3 over 5 here. So alpha is cos inverse of 3 over 5, which is shift cos inverse of our answer. That gives us 53.13. Okay, let's find beta now. So we can write beta equals to cos inverse of all this. So these two squares we have to add, 40 square plus 50 square, take away 30 square divided by 2 times 40 times 50. Clear? And we can find the angle. Okay, so let's do the inside first, as we did earlier. 40 square plus 50 square minus 30 square divided by, within brackets, 2 times 40 times 50, 4 over 5, and we'll do shift cos inverse of our answer, which is 36.8. We can write this 7. Okay. So we have these two angles. Now once we know these two angles, we can make the vector diagram, right? So you should remember this is the position diagram. And now let's make vector diagram. Now many test papers, making vector and position diagram is a part of the question, right? So the resultant here is this much, which is how much? 30 times 9.8, sorry. We have 30 times 9.8, which is 294. So this is 294. Okay. Right. So now we have our, so we have this one tension T1, this is tension T2. Okay. So the angles, so beta is this angle, which is same as this angle, correct? And beta is 36.87. let's call this as 36.9. The other angle alpha is 53.13. 53.13. Okay. Those are the angles. Now, we want tension T1, so we'll also need this angle, correct? So that angle is going to be 90 minus 53.13. 90 minus 53.13, which is 36.87. So this angle is 36.87. Okay. So that is 36.87, correct? Let's add these two angles and see what do we get, right? 3, 4, and 5 is basically 90 degrees, if you remember. So what we have here is 3, 4, and 5, which is basically 90 degrees, right? So if you add them, you should get 90 degrees, correct? Okay, so with 90 degrees, it is much simpler to solve anyway. Now we can find what T1 is. So this side is 36.87, and let's use sine law itself, but I could have used, as you can understand, this is the right angle. This is the right angle, correct? Okay. So anyway, so we'll write the tension T1 over the angle, which is sine of 36.87, should be equal to 294 divided by sine of, we'll add these two, 36.9 plus 53.13. Imagine that we didn't notice that this is 90 degrees, okay? That's fine. So T1 is equals to 294 times sine of 36.87 over, which is sine of 90 degrees, which is 1, right? So, okay. So we get 294 times sine of 36.87. 176.4. Okay, so the closest here is 177, so that is our answer. Is that so? I hope the steps are absolutely clear. I didn't notice that this is a right triangle, otherwise we would have had a different approach to find the solution, especially for the angles, correct? Anyway, follow the procedure, which is we need to find these angles using cosine law in general. Then you make your vector diagram as we did. Since we need to find T1, it was important to find that angle, which is 90 minus 53.13. Then we use the sine law to find T1. Perfect. Now here is the last question, question number 10. It says the resultant of two forces A and B is 8 newtons acting due north. A has a magnitude of 4 Newton acting due northeast. Determine the magnitude and direction of B. Okay, so we have a resultant which is acting north, correct? That is the resultant of two forces A and B, where A is a magnitude of 5 newtons acting northeast. So A is northeast, means with north it makes an angle of 45 degrees, right? So that is northeast. And we need to find the magnitude and direction of B. Okay. So say this is northeast. Now, since our resultant is like this, what we could do here is, let me just extend this a bit more, just to make it general. And let's say this is our another force, right? So these are the two forces, A and B, and that is the resultant R, which is acting north. Is that clear to you, right? So let this be the system of forces. And now Determine the magnitude and direction of force B. That's what we need to figure out. Okay. So in this particular case, we have a resultant of two forces A and B is 8 newtons. So this is 8. A has a magnitude of 5, so this magnitude is 5. We know that this angle here is 45 degrees and this is 90 degrees. Since this is 45 degrees, this one is also 45 degrees. Let's call this as O, okay, PQ, let's call this. So we can use cosine law to find B, right? So B square will be equal to 5 square plus 8 square minus 2 times 5 times 8 times cos of 45 degrees. Correct? And B will be square root of this, whatever we get. So let's calculate. We have 5 square plus 8 square minus 2 times 5 times 8 times cos of 45 degrees, and we'll do square root of this answer. That gives us 5.69. Okay, so we didn't calculate that. 5.69 is what we get, right? Okay. So we know the magnitude of B is 5.69. Let's say 5.7. Now we need to find this angle. Let's call this angle as theta. Okay. 5.7, we have two solutions, A or B, right? So we have to now check which angle is the correct angle. So to get the angle, we can apply the sine law. So we have sine of theta over 5 equals to sine of, okay, we can use 45, right, over the side which we just found, which is 5.7. Okay. So from here we can find what theta is. So that gives you theta is sine inverse of 5 divided by 5.7 times sine of 45 degrees. Clear? So that is how we could do it. Okay. So we'll first find the inside and then we'll do sine inverse. So 5 divided by 5.7 times sine of 45, and then we'll do shift sine inverse of our answer, which is equal to 38.3 degrees. Okay. So the closest is 38.7. So option B is the right option, right? So from north, 38.7 degrees west. That makes sense, right? Okay. So that is how we are going to solve this particular question. So it's kind of critical to sketch this diagram. There was a couple of ways we could have sketched it. This is definitely looks appropriate. I hope with this you have clear concept of how to work with multiple forces acting at a point, what is equivalent force, how do we find components of forces, and how do we find tension in the string. Feel free to write your comment, share your views, and if you subscribe to my videos, that'd be great. Thanks for watching and all the best.